In this video lesson, we'll take a look at arrays as function arguments, and then finally the two-dimensional array. Arrays can be passed as a function argument, and so to pass an array to a function, we use the array name. So where previously, as I wanted to process an array, whether it's to display the array, take something from the array, copy one array over to the other, we needed to use an address. But if I want to pass an array to a function, the whole array, then I only need to reference the whole array when I pass it as an argument. So here we have our original array called tests. We're passing it to the function show scores. So we're passing the whole array. So this indicates I'm passing the whole array. When I look at the prototype, I can see that the type of data it's going to accept is an array of integer type. So I do need to use the square brackets in the formal function header to describe what it is that the function accepts, but I do not use the brackets when I pass the actual parameter. Okay, but I do in the formal definition of the parameter with regards to the function header. So this is just telling me that this function is accepting an array as its argument to use within the body of the array. Okay, so we call by passing the entire array. Now I can pass a single element of the array, and we'll take a look at that shortly. When passing an array to a function, it's common to pass the array size as well. So here we're passing the array tests, and I'm also passing its size. In some languages, we can find the size of the array, and we don't have to worry about passing the size of the array. We can actually get that through another function called the size of the array. So here we can see an example of them passing in the prototype. We know it's going to pass an array and a regular integer. Here in the formal function header, we can see that it is passing an array. I wouldn't call it the same. That's just bad programming practice, but it's passing an array of integer type and then also passing an integer as a second parameter, which in this case is going to represent the size of the array. So here we can see an example of the array of size 9. They gave it an initialization list, size 8, gave it an initialization list. So when they go to pass it, so this is a call passing the entire array, not just a piece of the array, but the entire array. And so here we can see numbers, which is the array itself. And then we can see the size of the array being passed at the same time. Here in show values, we can see that the array, which we called numbers, is going to be represented by the variable name nums in the body of the function. I strongly discourage, I have seen nothing but problems when students use the same name in the main function as they do in the function header of a different function when they're using the same name as the parameter name. You just cause yourself trouble. I've tried to discourage that all year. I will continue to discourage that. They also pass the size, which is then used to process the array. So this makes this algorithm very generic. It's just going to display all of the elements in the array, regardless of what the array represents. This will just display all of the elements in the array because it's passing the size, so we know how large to make the loop. And nums is taking on a copy of the array in memory, and it will display the values of that 8-element array. We can modify arrays in a function, and I alluded to this back in the first video. Array names and functions are like reference variables. Any changes made to the array in a function are reflected in the actual array of the calling function. Okay, we need to exercise a great deal of caution, okay, so that we're not changing an array if we don't want to change the array. In the next chapter, we'll look at sorting an array, so we want to change the order of the array, but you want to be mindful that you're not inadvertently changing the array. So where in the previous, like when we wrote swap, and we wrote it to accept int ampersand A, int ampersand B, we had to use the ampersand to say, hey, I'm passing A and B as reference. So anything that you do to A and B while you're in the function swap will be reflected back to the main function that called it in memory. So the actual memory changes. I don't need an ampersand to pass an array by reference to a function. That distinction automatically will happen. So no matter what I do to the array, if I alter all the values in the array, that will be reflected back in the main memory when I go to process that array back in the main function from where it was called. So we need to keep that in mind. So let's talk about two-dimensional arrays. We've been talking about one-dimensional arrays up until this point. Two-dimensional arrays share all the same properties as the one-dimensional array, except for we know that we are going to control the idea of rows and columns in an array that is multidimensional. So if we recall from previous experience, multidimensional array is made up of a series of rows and columns. The rows are the horizontal representation, and the columns are the vertical representation, still using that same 0 to n minus 1 in its indexing. Whoops, 1, 2, 3, 0, 1, 2, 3, 4, in order to reference a location in memory. So it's going to have two pieces to the address versus the one. So here we can see an example of them declaring the array called exams. They've given it a size for rows and columns. So that one's going to be a 4x3, which is a little bit different than the one that I have drawn for you here. It does have 4 rows, but I have more than 3 columns. So if I would do this, this would be the one that's being declared here, is this space right here. We can define, so for multiple sets of data, it will be similar to a table or a spreadsheet, this 2D array. The first declarator is always for numbers, that hasn't changed, and the second one represents the columns. Okay, we can operate on 2D arrays in row major or column major process. We did only row major up until now, where we process directly through the row. Okay, when we're looking at column major, we will process through by column and not directly by row. And so we're having to refocus our indexing, but we will add that to our understanding of two-dimensional arrays. So here's an example of a two-dimensional array in memory, our exams, which is 4 rows and 3 columns. You can see example of what that indexing would look like. So rather than just one element, it is 2. If we recall back from basic last year, if I had one called score, we actually had parentheses and it looked more like an ordered pair. Versus here, 2 sets of straight brackets indicating the addressing. So it's a little different. This is what we had in basic. Okay, but if I want to reference exams at 0, 0, then I need to put them in separate sets of brackets. We always use 2 subscripts when I am referencing a two-dimensional array. So here we have a two-dimensional array called sums. It is a 3 by 4. This program will calculate the total sales for a company. And so this one's going to hold total sales. Here we can see that it is going to, we're using a nested loop. Okay, nested loops are used all the time with two-dimensional arrays since I have to control both the rows and both the columns. So this one, the divisions are going to be stored based by row, okay, and then each quarter is going to be representative of each of the columns. So we are going to have division 1 will be stored here at index 0. Division 2 is going to be stored at index 1, and so on. So here they're talking about division 1, and then they're going to fill with the quarterly sales. They will go across for each quarter. So the quarters are stored here, quarter 1, quarter 2, quarter 3, and quarter 4. For each of my divisions, it will go through and it will fill. This is filling in row major, so it will fill all 4, fails the inner loop, goes out and increments the row representing a new division, reinitializes the inner loop, so it will fill each column of the second row for division 2, fails the inner loop, goes back up, increments to division 3. So division 3 is going to be represented by row 2, and it's going to fill in the sales for each quarter, and it's going to do that however many times num division is. This is a nested loop that's going to add all the elements in the array. And so again, using, they're going to find total sales for the entire array. So this one is going to go through and it's going to take each division, sum all of them in column or row major process. So it's going to sum all of them for division 1. Then it will fail the loop and move on to division 2, and it will sum all the ones then on top of division 1 with division 2, process through for division 3, and so on. So here we can see they enter all the sales for division 1 for each quarter, all the sales for division 2 for each quarter, all the sales for 3 for the 4 quarters, and then they ran the summing of the series of the two-dimensional array, and we end up with this value after summing the series of all of these values. We can initialize using an initialization list for an array. We can give it size at the same time. Here they're making a 2 by 2. So here you can see in pairs of 2. They do let you know that you do not need the inner curly braces, but it really helps with identifying where they should be within the array, so that this is going to be row 0, this represents row 1. So it helps us better understand visually how it should be displayed in the array. And again, they just use 2 different lines just for the sake of wrapping it around. Sometimes you'll see that because then it looks more representative of what the array might look like in memory. Okay. Now, they do note here, though, if you do drop out the zeros and don't have enough, or drop out the curly braces, it will initialize with zeros. Two-dimensional arrays as a parameter. So this is a little different. Again, I can pass the entire array just by name. But inside of the prototype and the function header, I do need to include at minimum the column size. I can omit the row size, but I must include the column size in the definition of the function header and the prototype. So that's a little different than when we had the one-dimensional array. So we have to keep an eye out for that.